So now let's take a look at how we can transfer all the geometry we created in Blender into Fusion. The great part I really like or love actually about Fusion is Blender for me is a very fast polygonal modeler. I can quickly explore different ideas. I can harness the power of animation tools and apply that actually for industrial design. And because Fusion has a T-spline module built in, I can continue using all the geometry I created in Blender and bring it over into Fusion. And again, I come from the school of thought where a software is just a tool and you just pick each tool which is best suitable for your task. So for example, all this was like exploring an idea and maybe doing some mock-ups. And now, let's say I finalized my idea or solidified on it, and now I want to work on creating actual industrial strength B-rep surfaces from it. And that's just a great part that everything we did here, we can simply send over to Fusion and then continue working on it there. However, there is one small problem right now, and that is Blender has the ability to crease edges based on a numeric input. So for example, you can see, let's say maybe on this layer, how this front edge has a value of 9 and this back edge has a value of 0.2. So here I have a nice and soft rounding, and then to the front, for example, it gets sharper. Same like with this edge here, it gets stronger or more crisp the more I go to the front. So the problem is because Fusion only can soften or sharpen an edge, it can't really currently have degrees in between. We have to do a workaround. And as far as I know, this feature is also a hot topic for the developers. So sooner or later, I think you will have this inside Fusion. So at that point, then this process I'm going to show you now, you don't actually then even have to consider anymore. But as long as Fusion cannot provide you a feature like the creasing, we have to see how we can modify this geometry so we can get something into Fusion that is as close as possible to my design inside Blender. So for example, what would be a possibility to do or a standard workflow? Let's say I turn off the subsurface modifier, and then I have this shell selected, go to File, Export, Wavefront, and for example, selection only, apply modifier, okay, and then I call this one low res. And maybe here I have a 1. And let's go export. Let's maybe call this one mid-res and maybe go to a 3. And you see the higher the numbers, the better the edge results. But if I go into shaded mode with my optimal display turned off, you can see that with each higher step, the amount of polygons is getting insanely high, and that actually is not ideal for T-splines, because T-splines pretty much works like the subsurface in Blender. It just softens your surface inside based on a really low polygon cage. So you want to feed it with the correct diet, so small polygon models. Let's go back to maybe 3 and export this one. Let's maybe call this one high res. And the problem is the denser the mesh, the more Fusion actually has to work to convert it. So let's go to Fusion. I created a document already, and I'm going to insert, for example, those meshes. The low res, move this one to the side, maybe to there. Then let's insert the mid-res. And let's insert the high res. Oh, I is misspelled. Okay. So they all look very, very similar to each other, but are fundamentally different in precision. So if we select all and then, for example, say convert to T-spline body, this is going to take a little bit because I have 3 objects the software has to convert at once. The far on the left, Fusion, if I would do the conversion alone, would quite quickly create. The second one takes a little bit longer, and the right one will take a little bit longer. But actually, because I'm only working on the roof, the conversion time wasn't really as long or as bad. But if I would bring over the complete car model, it could take a little bit longer. So let's move this to here. And then let's change the shading to only shaded, no edges. And let's take a look at what we have. So far left compared to far right, you can see the higher the mesh density, the better, for example, those edge creasings carry over. So on the left side, everything looks very soft and smooth, very uniform. The one in the middle is not too bad. It's a good compromise. The one on the right is actually more detailed. So the problem you can face with this idea is if I now, instead of this roof, decide to bring over this complete car, that's the amount of polygons I have to bring over. So preferably it can work with Fusion, but it can mean that it has to work for a really long time. And it's also not really efficient because I provide so much extra information. For example, all those meshes in between I don't really need because all I need are just loop cuts along those crease edges. And this actually brings me now to the second workaround, which at this point might maybe be a little bit more efficient. So for example, let me move this one onto a different layer. So instead of using this creasing, I simply start beveling those edges and then scale those sections separately. So what does this mean? I could, go ahead and, for example, add a loop cut. So I add more geometry, but then I also have the center line, and that's maybe not really what I want. If I select this complete edge and then press Ctrl B, I can bevel this edge. And I just only need maybe to put this, to move my mouse a little bit, and then leave it there, turn the rounding off, and let's take a look what we have. So the fillet basically I put in is very uniform. Now if I want to make a nice transition, let's say I do the same here as well, I actually have to perform a little bit of scaling. So for example, let's assume here in the front those are fine. Then I can go ahead, for example, select this edge and then start scaling this up and scaling this up furthermore. So you see, I'm just changing the length of those edges, and those actually will then result in much bigger, kind of like blends between, for example, the side and the horizontal surface. And if essentially this is nothing else than a blend surface or a fillet, the NURB software would do for us automatically. Only trick is I need to try to be really conscious about the different steps, how I scale it. But there you can see that this already starts to look quite nice. And how I'm sculpting those details out. Maybe here I scale them together to pinch it more. And I'm only selecting this edge, and when you select an edge and you press scale, you move those 2 points towards each other. So I'm kind of like, think about this as playing with the cross section of the fillet. Maybe let's turn on the projection of the editing cage right onto the mesh, and let's take a look. And yeah, this is actually quite acceptable. Maybe let's make an overlay with the original surface. So the front part I modified a little bit, of course, but you can see, for example, in the back, I'm very close to the original design. So the advantage of this is you get basically the same result. You just have to work a little bit harder or invest more time by sculpting those surface transitions. And that's not really very difficult. And it's probably also a good task to do, because it kind of like every manual step sharpens your eyes a lot. So you start paying attention for details and see those. Okay, perfect. Now if I, for example, turn the subsurface off and then say export, for example, new, and let's go to Fusion, insert, where is it? There. There's the mesh, and let's convert it. So you see exactly the same result. Very nice soft rounding in the back, nice crisp lines in the front, and the conversion, the import function was very fast. So I make it a lot easier for Fusion to, when I bring the software in, to import it, convert it, and also when I have to convert those later then to B-reps. Again, maybe let's try this one out for a second. Let's move this one up. It doesn't. Okay, then I delete you. Let's select all those T-splines and convert them into B-reps. And let's then take a look at the end result. Visual style, shaded edge. No. Oh, where are they not visible? Maybe by accident I turned something off. Oh, okay. Well, but you notice those are now my B reps. Oh, those are all one surfaces. So of course that's the reason why you don't see any lines on it. But so you see that the conversion then into a NURB surface was not really a problem as well. Even the NURB surface perfectly matches the T-spline object. And that's basically also the reason why T-spline is working a little bit different. While it borrows the idea of working with polygons like with Blender, however, it follows more the math concept of NURB surfaces, because that's the reason why you can, with a mouse click, convert it into B-reps. Okay, I would like to keep it at this. maybe one last small demo to show you, for example, what I would have to do. I'm just going to make a duplicate and put it onto here, because in my demo first, I was very easy to just round those linear edges. But then when you have something like this, where you have multiple edges, it might be a little bit more tricky, but it's not really impossible. So let's see maybe how I would approach this. So for example, I would like to round this edge. Maybe I can actually try to see what happens if I select all those edges at once, which I want to round. So let's say all those. So I can select them and then press Ctrl B, move my mouse slightly till it starts rounding it. And there you see now then it actually created those edge flows for me. Maybe I can turn the edge creasing off at this point. And let's take a look at the result. There are a few problems. So for example here, because I had like this line and this line and this line, I ended up with a nice rectangle. But here I ended up with a triangle. Yeah, and that's, in this case, I think I have to leave it this way. But for example, here I have a triangle and I don't necessarily want it to be there. So those 2 points, for example, with W, merge, at center, I fuse them together. So I end up again with rectangles. So this is a rectangle, 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 rectangle. Okay. Let's take a look at some other parts. For example, here, the same merge, in this case, at the last point I selected. And this is all fine as well. Yeah, and at this point, then, like before, I can just go ahead and start working on my model. And maybe start scaling those parts apart. And there is probably a small problem I notice right now. So just scaling, for example, is a little bit problematic. Let me really overimpose this. So you see that I push this point down into the surface. So instead of scaling, what I have to do now is actually something similar. Edge slide works actually much better. So I can select this edge and then say, maybe I start with this one, GG. And so I slide this edge along those connecting edges. So I change kind of like the flow of the geometry a little bit. And maybe here as well, GG. No, actually here I would like just to select this point, GG. So see, I can also do it with a point, GG, GG. This one has to follow this a little bit. And then, for example, up here again, I can press GG and with the sliding, simply adjust my design. And of course, then the art is just trying to, when you make those transitions, be nice and even. So For example, let's take a look in the top. You can see that, for example, this is a little bit crooked. So at this point, maybe because I want to have an arc, has to go down a little bit. So I press GG and then try to go over this edge I need there. This one maybe can go in a little bit or upwards. So I try to see or project a curve flow through those. And then quite quickly you can see I end up with the same result with those nice rounded corners or edges, and then again can pass a very simple polygon model to Fusion. It's a little bit more labor intensive, but you know, at the same time you also have more control, because instead of having just a value you need to put in, I actually really manipulate that geometry and can have a little bit more modeling finesse applied to it. And as I said, very often during class, sometimes all the stuff looks very intimidating, but the only way to get good at it is simply practicing and trying it out. And then the more you practice it, the more you get fluid in it, and then the less you start actually hesitating to do something. You just simply do it, and because you're so fast, you get the results pretty quickly. Okay, so let's stop this video about how to get different surfaces with different crease values into Fusion, and then I will create a new video which talks about then, for example, bringing over the windows.